Okay, here's warm-up 5.6. We're going to name the theorems described in these two statements here. The part A says if two sides of a triangle are congruent, I'm going to draw a little picture here. Okay, if two sides are congruent, okay, then the two angles opposite those sides are also congruent. Okay, so that's, I just drew a picture of what theorem we're trying to show that tells us this happens. Part B says if two angles in a triangle are congruent, then the sides opposite those angles are congruent. So it's the reverse, right? So these are converses of each other. All right, so our first one, one of these is the base angles theorem, also known as the isosceles triangle theorem. And the other one's the converse of that. And the way I remember which is the original theorem and which is the converse, this one we start off with an isosceles triangle. This is an isosceles triangle, okay? And that we can say in an isosceles triangle, the two base angles are congruent. This one, it's true, this does end up being an isosceles triangle, but the definition of an isosceles triangle is two congruent sides, not two congruent angles. So in the original theorem, we start off with an isosceles triangle, and then we say something about the triangle from there. The converse, we go in the reverse order. Okay, so this is the base angles theorem. I like to call it the isosceles triangle theorem, but that's what Big Ideas calls it. And then we have the converse of that same theorem here. Or you could call it the base angles theorem converse. Okay. All right, next up we've got, we're solving for x on this problem. So we've got some isosceles triangles in this picture, okay? So looking at that top triangle, hey, that's isosceles. So I've got these two congruent sides, and across from those two congruent sides would be two congruent angles, okay? So the two base angles are congruent. So it's really important that you get the correct two sides, the correct two angles being congruent. Some people will put 59 degrees down there, and that's going to throw everything off. Okay, so one way to figure this out, the two congruent sides are called legs. The non-congruent side is the base, and the base angles will be touching the two base angles will touch the base. So these are my congruent angles here. So this must be 59 degrees. Okay. Moving to the other triangle, we've got another isosceles triangle here. This would be the base. It's the non-congruent side. So the two angles touching that are going to be congruent. Okay. Now in this triangle, I don't have any of the angle measures, but I can use that 59 degrees because I've got vertical angles here, right? I've got two intersecting lines, and the angles across from each other are going to be congruent to each other. So that means that one's 59 degrees, and so is that one. And now I got enough to solve for x. So what I can do is say x plus 59 equals 180. Okay, because the three angles in a triangle are going to add up to 180 degrees. So I combine those. Now I'm going to subtract 118 from both sides. And I've got 62. So x equals 62. And this is 62 degrees. It's the measure of that angle there. Okay. All right. And then the last problem. Again, we've got some isosceles triangles here. So on a problem like this, I see this very often that people say, oh, this is 90 degrees here, so this must be 45 and 45. But we don't know that this bisects that angle. We don't know that that 90 is split into 45 and 45. Maybe it's split into 40 and 50. We don't really know. You can't go just based on looks. So let's go with the given information. We do know that whole angle is 90 degrees, but we don't know how that 90 is split up. So let's use the isosceles triangles we have. Okay. In that top triangle, this would be the base. So the two angles touching that are going to be congruent to each other. Okay. And in the bottom triangle, this would be the base, so the two angles touching those are congruent to each other. And these aren't necessarily going to be 71 degrees, so I want to put two ticks here to show that those two are congruent, but they're not necessarily congruent to those two. Okay? Okay, so now I've got those angles marked, so let's see what else we can do. Well, let's start working with the 71s, okay? Now what I can do is I can figure out this angle. So let's just call that, I'm just making up a new variable. Let's say that this was y. So I can say y plus 71 is going to equal 180. Because in that top triangle, all three angles are going to add up to 180 degrees. Okay, so I'm going to combine the 71s into 142, and then to solve for y, I'm going to subtract 142. And y is going to come out to 38 degrees. So that means that this is 38 degrees. Okay? Now I still haven't solved the problem, but now I can deal with this corner because 38 plus x is going to equal 90, right? Those two angles together form the 90 degrees. So now I can say, okay, they are complementary. Okay, and I'll subtract 38. And that's going to be 52 degrees then. Okay, and I've solved for x. And that's the end of the warm-up. See you next time.